Alright guys, here's some of the solutions for the review guide for tonight. Here we go. First, since this is multiplying, we have to factor all four of the polynomials here so that we can see which common factors we can reduce. First polynomial is going to factor as x minus 4 times x plus 2. Bottom left is going to factor as x plus 4, x minus 3. Second one. Top right is going to be x plus 5, x minus 3, and then bottom right here is going to be x plus 2, or x plus 5 times x plus 2. Now we're going to reduce common factors. They're going to divide out and be 1. That divided by that is 1. X minus 3 over x minus 3 is 1. X plus 5 over x plus 5 is also 1. And we're left with x minus 4 over x plus 4. Now we can't reduce that anymore because x and x are factors of a term in the numerator and denominator. They are not factors of the entire numerator and factors of the entire denominator. So let's take a look at the second equation. Factor the top left. It's going to be x minus 8 times x plus 3. Bottom left is going to be 2x times 3 plus x. And then I'm going to flip this because it's divided by a fraction, so we multiply by its reciprocal. 5x squared over 8 minus x. Now we're going to see, since it's all multiplying, we just have a fraction multiplying by a fraction. We can actually cross cancel, or we can cancel common factors that show up. This x plus 3 and that 3 plus x, if you commute that, it's the same factor. This x right here reduces with that x squared. X squared over x just becomes x in the numerator. 5 over 2 doesn't reduce, but what you can also notice is this 8 minus x in the denominator will reduce with the x minus 8 as long as we factor out a negative 1. For instance, if I factor out a negative 1 here, it becomes negative 1 times negative 8 plus x, and then I commute those two terms. It becomes negative x minus 8. And then you'll see that the common factors. So that and that reduce, we need to remember that we need to put the negative out in front as well. So it's negative 5x over 2. Now, you'll notice I'm not writing restrictions there. Not that important at this point. Where that comes into play and where you have to do it is going to be in the graphing. If you reduce a function and use that to graph, it's going to represent the holes of the function. All right, let's look at the second one. This is subtraction. Now, for subtraction, to subtract two fractions, we have to have the same denominator, so that's what we're going to do. To figure out what the denominator is, it's going to be x minus 3. We're going to factor to see what factors are actually in the denominators so that we can work to get a common denominator. That should be 3. Alright, now we'll notice from the first fraction has a x minus 3 and an x minus 2. The second fraction has a x plus 3, which isn't the same, and then it has an x minus 3, and that's the same. We're going to line them up. So that now we can just go ahead and read straight down. The common denominator would be x minus 3, x minus 2, and then x plus 3. So now we can kind of see what the first fraction needs so that the denominator is the same. The first fraction is going to need that x plus 3. So we're going to multiply it by x plus 3 over x plus 3. Now the reason why we can do that is because we're actually multiplying by 1, which preserves the value of the fraction itself. But we're doing that so that we can get a common denominator on both of them. So now the common denominator is going to be x plus 3, x minus 3, x minus 2. Now the second fraction, we're going to turn around. It's going to need a x minus 2. So we're going to multiply top and bottom of that fraction by x minus 2. So we're going to get minus 5 times x minus 2 on the numerator, and then the denominator is the same. And we could write that as a second minus a second fraction over the denominator if we wanted. But we know when we subtract fractions, we keep the same denominator and just add or subtract the numerators. So right now we're going to multiply out the numerator and simplify it. 2x squared minus 3 plus 5x. That's 6 minus 3. Silly. It's actually going to be a 5x, positive 3x, minus 9. Then we got to make sure to distribute that negative right there. So negative 5x plus 10 all over the common denominator. And then I'm going to continue to simplify here. So we're left with 2x squared minus 2x plus 1 all over x plus 3, x minus 3, x minus 2. So this guy here, right here is not going to factor. The numerator is not going to factor anymore, so we're consistent. And that's our response. Now our second question, number 4, we're adding two fractions. Again, we need the common denominator. So we're going to factor first, and then we're going to figure out what the common denominator is. Now I went ahead and factored both of those polynomials. We need a common denominator, so this common denominator is going to be a little intense as we get through it. You're going to notice that the first fraction is a 3x minus 4 and an x plus 2. The second fraction has a 2, I'm going to write that way out there, an x plus 1 and an x plus 2. So then the common denominator is going to be 3x minus 4. It's crazy. X plus 2, x plus 1, and then there's a 2 that's going to be out front. So then the first fraction, we're going to need to turn around and multiply it by the 2 times x plus 1, top and bottom. Then the second fraction, we're going to need to multiply by 3x minus 4, 3x minus 4. And so then we rewrite that, so we get 3 times 2 times x plus 1 plus 4x times 3x minus 4 all over the common denominator. That's right up there. I just don't want to rewrite it right now. And we distribute that 6 right there. So we get 6x plus 6 plus 12x squared minus 16x all over the common denominator. And then we're going to simplify one more time. 12x squared. That's going to be minus 10x plus 6 all over the common denominator of 2 times 3x minus 4. X plus 2, x plus 1. Now you're going to notice there's a factor of a 2 in the numerator, so we're going to factor that out as well. And then that's going to reduce down here. Now we get a common factor of a 2, and we're going to reduce it one more time. That's going to be our final answer there. Let's work on these. Now these are complex fractions. The way we did it was we multiplied top and bottom numerator and denominator of the big fraction by the common denominator. In this case, it's going to be 2x plus 3 times x plus 1. 2x plus 3 times x plus 1. Then we're going to distribute this whole thing to there, that whole thing to there, and there. And some of the factors are going to reduce. The 2x plus 3 and the 2x plus 3 are going to reduce. So we're left with 3 times x plus 1 minus. In the second fraction, x plus 1 and x plus 1 are going to reduce. So we get x times 2x plus 3 all over. Same kind of situation here. We get 2x times 2x plus 3 plus 5 times x plus 1. Now we're going to reduce and simplify. So we get 3x plus 3 minus 2x squared minus 3x all over 4x squared plus 6x plus 5x plus 5. We're going to simplify here. We get negative 2x squared plus 3. In the denominator, we get 4x squared plus 11x plus 5, and that's an acceptable answer there. Now let's go ahead and tackle the number 6. We're going to multiply through by the common denominator, but to do that, we first need to figure out what the common denominator is. We got to factor that denominator right there as x plus 1 times x plus 9. So then our common denominator is going to be x plus 1, x plus 9. And don't forget that lonely 5. So 5, x plus 1, x plus 9. Then we're going to distribute that to each one of the fractions. And we're going to then do 5x plus 1, so what's the remainder, plus x plus 1, x plus 9. Then on the denominator, we're going to get 10, 2 times 5. Alright, we're going to simplify and reduce. 5x plus 5 plus x squared plus 10x plus 9 all over 10, which then is going to equal x squared plus 15x plus 14 all over 10. And there you go.